Our next lesson about polynomials is called multiplying monomials. So a monomial, if you remember from our first lesson this unit, is one term. Okay, so it's like 2x, 3x to the fourth, whatever, one term. So we're going to be multiplying one term through to a polynomial is basically all you're going to be learning today. There's a little bit of review that we need to cover before we just get into the examples. And if you look down at the bottom, basically these are just distributing problems. Okay, there's a couple key things that you have to remember though to get these right. So keep in mind what we did last lesson. If I'm just adding polynomials, like 5x cubed plus 2x cubed, that equals 7x cubed. There's 5 here, there's 2 here, so there's 7x cubes in this polynomial right here. Okay, so think to yourself, what operation is being used? Well, obviously, I was just doing addition. Did I change the exponent? No, never when you're doing addition do you add the exponents together. You're just counting how many x cubes there are in this problem. Okay, never change the exponent when you're adding. Shift gears then and think about what we did last unit when we were multiplying exponents. If I had like a to the fourth times a squared, that equals a to the sixth. Remember, that's like a times a. Really, I'm just counting how many a's there are, and there's 6 of them, so that's a to the sixth. So when you're multiplying, does the exponent change? Yes, it does. So this stuff, it just kind of all looks very similar, but you have to remember a lot of different rules. Okay, so be careful here. And again, this like ties in things we did last unit, which can be tough for people to kind of carry those skills over. Okay, so be very careful. Now, the big idea is what we kind of just talked about up here. Big thing to remember is that when you're multiplying terms, and that's what we're doing today, we're multiplying monomials. So say, for example, I've got something like 5y to the 8th times 2y to the 4th. If I think about what that equals, and again, I saw this stuff last unit, I would do 5 times 2, which would be 10, and I would add the exponents, and I would say y to the 12th. So the big idea for today is that when you're multiplying terms, you've got to add the exponents. Don't forget. Okay, all I'm doing is distributing, so check it out. Multiply, make sure you note this. Write your answer in standard form. That means biggest exponent to smallest exponent. All I'm doing is distributing, but I have to remember to add the exponents because I'm multiplying when I distribute. So I'm going to put ones in there so I don't forget. That's x to the 1, x to the 1. You just multiply the big numbers and then you add the exponents. So that's like 5 times 1, which would obviously just be 5. People will make the mistake of just saying x, but it's x to the 1 times x to the 1. I know I have to add those x's, and that's x squared. Then when I do 5x times 3, I multiply the 5 and the 3 to get 15. There's no x's here to combine it with, but I did have that original one on the monomial out front, so I've got to say that that's 15x. Just carry that x down. This is in standard form. It goes x squared and then x to the 1, so that's my answer. Okay, honestly guys, this is all like repetition. It's kind of the same stuff, so it's just a lot of practice. When I distribute this monomial, 7m squared, to the binomial in parentheses, 7m squared times 2m, that would be 14. Add your exponents, m to the third. 7m squared times 1 is just that exact same term, 7m squared. Next one. So you multiply the numbers, negative 24, add the y's. So y to the third, y to the 1, that's y to the fourth. Okay, be careful with your sign. Negative 4 times negative 7 is positive 28. If there's no y's on the second term, then you just bring these y's down. So it's 28y to the third as my answer. All right, two more. So I'm just distributing again. Let's see, that would be negative 12 times 5 is negative 60. There's no x's here, so I just bring the x squared down. Negative 12 times negative 3 is positive 36. That'd be x to the fourth. And then that would be plus 12x squared. Here's an example where they're going to try to get you. This is not in standard form. X to the fourth is the biggest exponent. That needs to come first. Okay, so you got to write that guy first. Also realize that I can combine the x's, x squareds, right here. So it's negative 60 plus 12. So you got to rewrite this. Otherwise, it's just not the best answer it could be. And negative 60 plus 12 is negative 48 x squared. That's my answer. All right, one more on this side. So this would be 14x to the fifth. Multiply the numbers, add the exponents. 2x cubed times negative 5x would be negative 10x to the fourth plus 8x to the third. Bring your x to the third down to the 8 if there's none to combine it with here. It goes 5, 4, 3, so that's in standard form. I'm good. All right, I want you guys to try the next two. Honestly, they're all like very similar. If you notice though, number 7 has x's and y's, so maybe you want to watch me do number 8 before you go and do number 7. You're still distributing this monomial out front. You're just multiplying. Be careful though. So take it one piece at a time. You got to multiply the numbers. So it's negative 1 times 2, which would be negative 2. You're still adding exponents, so it's x squared and x squared. That'd be x to the fourth. Then you would just add the exponents for the y's. There's no y's on the 2x squared, so I just bring the y to the third here down. Okay, when I multiply these two terms, so negative 1 times negative 5 is positive 5. I know the exponents here are 1 and 1, so when I combine and add the exponents for the x's, I get x to the 3. When I combine for the y's, I get y to the fourth. Then distribute to the last term, so negative 1 times positive 1 is negative 1. There's no x's here, so I just bring the x squared down and add the y's together, y to the 6. I'm not big on you like really worrying about standard form for that when there's two different variables. I just want to check to see that you can like track all that and follow it, so kind of just leave it as is. That's good. Okay, so you guys try 6 and 7. Yay, we're going to end with geometry again. So I know a lot of this stuff doesn't seem very applicable, but it's super important in the math world, and you will see a lot of this stuff show up next year in geometry. So having these skills, being able to multiply monomials, is just really important. So they want me to find the area of these two shapes. Well, you got to remember how you find area of shapes first. If you forget to find the area, or like how much space this kind of takes up here, for a rectangle, it's length times width. For a triangle is half of a rectangle, so the area is like length times width. If it's a triangle, we say base times height. And since it's half of a rectangle, we just half it. So half base times height, if you forget that. All right, rectangle is pretty basic though. I just got to multiply these two sides. What you have to remember is that if there's an addition or subtraction problem anywhere here, you have to put it in parentheses. Because when I multiply, I cannot forget that I have to distribute the 3x to both of those terms. Okay, so be careful. Remember that there's ones on the x's here. So when you distribute this monomial, you multiply the 3 and the 8, and you add the exponents together. Then 3x times 5 would be negative 15, and just bring the x down. Doesn't mean a whole lot to me, but that would be the area of that rectangle. For the triangle, here's what I would do. I would worry about the half at the end. I would start the same way. I'd put parentheses around that addition problem. And I would distribute the monomial. So I would do like base times height first. Careful with your exponents. I'm going to write them in. So that would be 40y to the third plus 8y squared. Then I would worry about the half part. Okay, if you stopped right there, that'd be the area of like this whole thing. But obviously I want to cut that in half. So another way to like cut in half, it would be just to divide both terms, or whatever terms were there, by 2. That's taking half of them. So the answer would then just be 20, don't change the y's, plus 4y squared.